Good morning and welcome to part two of day 9, which is work that we'll be spending all day today on looking at learning number bonds and number facts as well. Hopefully people who are joining us now have watched at least part of the first video for today. As I say, if you're working in Key Stage 2 and beyond, then, or even in Year 2 and beyond, then obviously this part of the video might be, or this second part might be more relevant, but it's definitely worth having a brief run through some of the stuff on part 1, because we do look at a lot of resources and a lot of images that can be used and developed in a different way in Years 2, 3, 4 and beyond. So this is learning number bonds and number facts part 2, where we're going to take bonds to 20, and we're going to establish those, and then we're going to look at songs, models, images and resources, and then finally a little bit of abstract work that supports the learning and the reasoning of number bonds. The third song takes the idea of developing number bonds to 10 and builds it into 20. Again, really good to use egg boxes first. I think the egg box image is perfect for this one, to show the coins as they move from one box to another. Here you've got two of the sneaky criminals who've been given 20 coins to share fairly. Let's see if they can do it. It's a very fast-paced song, so I wouldn't be using this with a resource until the children have practiced doing this in class first. I want them to practice passing from one box to another and working in pairs and getting used to number bonds to 20. But there's that complete reference throughout of number bonds to 20, which obviously gets the children enjoying the song. But it is, as I say, fast-paced. I'll just watch it in action.
Oi, Bert.
Hello, Fred.
If you start with all 20, I'll keep taking one coin at a time until we've shared them fairly.
All right. Sounds good.
No coins for me.
20 for me.
1 coin for me.
19 for me.
2 coins for me.
18 for me.
Number bonds to 20. Keep going, Bert. 3 coins for me.
17 for me.
4 coins for me.
16 for me.
And again, just pause that there. Just bring that back a tad. There we go. That's better. And again, look at the idea of singing the song but pausing it at any time. 4 coins for me. We can see the 4 coins over here. What can we see over here? We can see a 10 and a 6. So you're seeing the 16 coins and 4 spaces. You're seeing 4 coins and you're seeing 16 spaces. Obviously, you'll have realised over the past few weeks how really keen I am on this arrangement, this 5 and a bit arrangement. You'll see that even more in the early years training next week. And unlike the number bond and the Farmer Pete song, where the sneaky criminals, they're in a straight line, and Farmer Pete's sheep were randomly arranged, where you can discuss how they've been arranged. This is the sort of arrangement I really like, so the children can visualise the number bond as well as sing the song, as well as learn the fact, they can see it at the same time. So again, you can put the instrumental version or the backing track version, or rather than actually having the PowerPoint up, and have the children doing this as well. I tend to show this first, though, so they can actually see what's happening, because then they can then replicate that back in class. I generally tend to sing it a cappella in class, and let the children. So I'll be saying to the children, 4 coins for me, and they shout 16 for me, and then we pass the next one over. 5 coins for me, 15 for me, and they pass the next one over. 6 coins for me, 14 for me. So we slow it down and we just do it bit by bit until they get used to doing it in a fast-paced way. We're going to continue now that image of 5 and a bit, but this time it's not actually 5 ones. What we're looking at now are 10s. So what we've got here is the same image that we've had before for 6, but it's actually 6 10s. So this allows us to make that link and this connection between 6 and 4, but also 60 and 40. There are 6 packets of sweets that we can see there, which means 4 packets of sweets will get me to 10. So I can bring those over and add them. 1, 2, 3, 4. But actually, there are 60 sweets, and therefore I'm going to put 40 sweets to join on, because each of them is worth 10. So 6 10s and 4 10s is 10 10s or 100. You'll notice I've set this out exactly like I set out the 10s frames. This is the vertical version, but we can also go horizontal. It really doesn't matter. And again, it doesn't matter if I do it this way around. You know, whatever fits on the table, I can still see 6 10s and I need 4 10s. That 6 can be over there, 6 10s and 4 10s. It can be done like that. It really doesn't matter. The conventional way tends to be that way, or as we showed before, vertically, where you build up a line of 10, 10, 20, 30, 40, 50, and then put the next one down here. The final song that I'm going to reference today is the drink survey one. Again, there's no way you're going to be able to replicate this with 100 drinks or a tea and coffee, but what you can certainly do is use a resource like the Slavonic Abacus to represent the amounts. You can use 100 square, but it's not as much fun as actually having something like the abacus. And before I'd even looked at the animation for this song, I'd already used this in class myself with the backing track and used the abacus to represent the numbers. And it was really interesting when I saw the animation that was created for this, that was the resource that was being used. There isn't anything that I've ever seen that's better for creating number bonds to 100. As you've just seen back in the classroom, it just gives you that instant number bond to 100 that you can create for any of the numbers. Let's briefly play this one, and you can see how this develops.
On Monday in my drink survey, 100 teachers had to say what they drank in morning break with their piece of chocolate cake. This is what they said. 90 had a cup of tea, 10 teachers had coffee.
What you'll see as the song develops is initially just different number bonds, as you can see, to 100 with multiples of 10. So you've got verse 2 on Tuesday, you've got a 70, which is 5 tens and 2 tens, with a 30. And then on Wednesday, we end up with double 50. So more teachers as the week progresses are drinking more coffee. That sounds about normal. And we move to Thursday, and we end up with a 40 and a 60. And then as we hit Friday, we end up with a 0 and a 100. Now, again, this is just multiples of 10. I've done this song many, many times in year 3, and I've done any number bond to 100. So I've used my abacus and made 32 and 68, or 55 and 45, and so on. And I've given out little abacuses to the children to do the same thing and create their own verses. And again, it doesn't have to be drink survey, it can be any survey that you want, as long as you can rhyme the 2 bits at the end. So you can create your own versions as well. So again, let's just think of the abacus not just as multiples of 10, which is relatively straightforward, but of any pair of numbers to make 100. That really is where the backing track comes into its to its own, because you can just play it and just put any numbers that you want in there and represent yourself back in class. We're still looking at the tens frame image. This time each jar represents 100, but there are 8 jars. So we're still looking really at 8 and 2 makes 10. I've got 8 full jars of sweets here, and I get another 2 full jars, and that gives me 10 jars of sweets. But what do they represent? Each jar of sweets represents 100. So I've actually got 800, and I add my 200, which gives me 10 hundreds, or 1,000. I don't actually have an image for 1,000 in the sweets, but I do know I've now got 1,000 sweets there. What's lovely about this, again, you can move them around and represent, I could actually create a Numicon image with them and do it that way. So I've got 800 and 200, makes my 1,000. I can even create double 400 using that dice image, and I still need 2 more to make 1,000. I could create 600 and 200, and I still need 200 to make 1,000. Even if it was random, like sweets on a shelf, which actually works quite nicely. You can actually often have your sweet jars on the shelves. What's happened? We've taken 2 of the jars away, or 200 away. There's 500 on the top, 300 underneath, and the 200 makes 1,000. So it doesn't really matter what resource you're using. We're always making that link between 8 and 2, 80 and 20, 800 and 200. I'm now going to show you number bonds using a resource that, to be honest, I've not used it that much over the past 8 days of training, but this is one of the resources that I tend to carry around schools with me and use all the time. This is the Slavonic Abacus. This one is a Fabacus, comes from a company called www.thefabacus.co.uk. They do produce this particular one, which is a smaller abacus. That's the Fabacus Mini. And also, you can see here, this is the basically whole class demonstration model. This is the Fabacus itself. I tend to use mainly the smaller one when I'm going into schools, but if I want to do, present to a big group or use the hall, I use the large scale Fabacus. It allows me to create numbers up to 100 really, really quickly. For the benefit of the video, I will use the smaller one, because it will be much easier to focus in on. So this is the Fabacus, and I can create any number up to 100 and get the number bond straight away. So initially, what number have we got there? We'll look at that picture. It's the 5 and a bit image.
It's not the egg box image, which would be 5 and a bit that way, but it's definitely still 5 and 1 is 6. That's why the colour changes at 5. We can see the 6, but we can also see the 4 that makes 10. Now I can choose any number up to 10. I can show the 3, and that goes obviously with the 7, so 3 and 7 makes 10. I can show the 1, and immediately I can see the 9, which is a 5 and a 4. That makes 10. So if I give children the little versions of these are from a company called Autopress. These are little ones, these are quite cheap, they're about £13 a piece. Again, they can use 7 and 3, they can show me 2 and 8, they can show me 5 and 5. So we've got a teacher demonstration model, the large model that come from the Abacus, this model that comes from Autopress. I use these all the time. I'm going to go back to this one now, and let's just see how we build up the idea of number bonds to 10 and build them up to 20 to 30 to 40. So I'm going to start off 6 and 4 makes 10. If I keep going with the 6, I've now got another 6. I had 6 and 4 makes 10. What have I now got is 16. 16 and 4 makes 20. If I keep that going, and this works really well in year 2, I've now got 26. 26 and 4 makes 30. Or 3 tens. You can see where this is going. 36 and 4 makes 40. Or 4 tens. 46 and 4 makes 50. Or 5 tens. I can then ask children to get their little abacuses and practice doing this all the way from 6 add 4 all the way down to the last one, where we end up with 96 add 4 makes 100. Now I can start with any number. I could start with 3. 3 and 7 makes 10. 13 and 7 makes 20. 23 and 7 makes 30. 33 and 7 makes 40. I can randomly come up with a number later on then. So I've got 50, 60, 73, which still goes with a 7, to make 80, or 8 tens. What we're doing now is we're reading the tens in the same way that we read the ones. So whereas up here we had, if we're looking at the number 8, we can see 8 ones here, which is 5 and 3. If I look down this way, I can see I've now got 5, 6, 7, 8 tens. So 8 tens makes 80. So I can do all sorts of different things with the abacus. I can do number bonds to 10, number bonds to multiples of 10, or, as we can see from this point, number bonds to 100. 8 tens and 2 tens, do that, make 10 tens, or 100. Again, you don't have to use the abacus going that way, you can use it either way. So again, I can pull my tens over this way. I've got 3 tens. How many more do I need to make 100? Well, 3 tens and 7 tens, or 30 and 70. I can go either. I can start at the bottom and say, right, let's have a look. How many have I got now? I've now got how many tens? 6 tens, and I add that to 4 tens, and again that makes 10 tens, or 100. So I've got quite a lot of scope with this. I can create any random number now. I'm going to randomly throw some counters over there. What number have I got? I've got the number 38, 3 tens and 8 ones. I'm going to add that to 2, and that gets me to 40. I can keep going now with a different number. I've got the number 44. If I add 54, 54, and I add 6 to make 60. I'm going to keep going from there. I'm going to add a few more, and I've now got the number, I've got 50, 60, 70, 80, 86, and 4 makes 90. We can see here, using the children's abacus, we can actually extend this to any number to 100. So I could say to the children, just show me any 2-digit number, and they can show me, for example, 36. 3 tens and 6 ones. I can see 36. How many more do I need to get to 100? I can actually see the whole answer there. I can see 50, 64, but I can do it in 2 steps. 36 and 4 makes 40, and 60 makes 100. If I now make another number, if I make the number, let's say 27, there's 27, that's not 27, that's 17, it's 27, there's 27, 2 tens and 7 ones. How many more do I need to make 100? I can see the whole number, but I'll do it in 2 stages. 27 add 3 is 30, add 70 is 100. If I start at the bottom and make the number 42, 42 and 8 makes 50, and 50 makes 100. Just give the children random 2-digit numbers. We can use the reasoning cards that we've been using all week. I could basically turn over a 2-digit number. Here it comes. Make that number. Too easy. Make, oh, typical multiples of 10. Shuffle up. Make that number 4. There's 4. What goes with 4 to make 100? 4 and 6 is 10, and 90 makes 100. Turn over. It's deliberately going to give me multiples of 10, isn't it, today? So let's turn over a few. So we've got, there we go, 42. There's 42. 10, 20, 30, 42, and 8 makes 50, and 50 makes 100. So 42 and 58. It's just an excellent resource. I've never seen a better resource for showing number bonds to 100. What I want to show you now, I would normally do this with a bigger abacus with the children, but I'm just going to show you this with a small one. This is how it goes into the abstract. We've got an obvious one there, 3 plus what equals 10, that's what we just did. 3 plus 7 equals 10. Underneath it is what we did earlier, 13 plus 7 equals 20. 23 plus 7 equals 30. But you can see what's happened here as we've moved down the board. I've started off writing almost the whole thing, then I've just left it. 23 plus what's going to come next? And hopefully the children in year 2 will say 7, and that'll get us to 30. 33 add, 7 equals 40. This one I've left with just the answer. What 2 numbers are going to go there? And if the children have followed the principles on the abacus, they'll go, it's going to be 43 and 7 makes 50. Can you prove it? And then we've got another blank one. Put any numbers that you want in there. What do you think is going to come next? We've done 10, 20, 30, 40, 50. Oh, this one must be 60. How am I going to make 60? If I follow that same pattern, it's going to be 53 and 7 makes 60. All the way down to the final one, where it's all blank, but that will be 93 plus 7. So again, I'll just show that one. The little abacus. There's 93 plus 7 equals 100. That activity can be extended over here. 10 plus what equals 100? Well, there's my 10, and there's my 90, there's my 20, and there's my 80. All the way down to 50 and 50, or to 100 and 0. 100 and 0 equals 100. How does that extend into bigger numbers? Well, we've got 110 now. Now for 110, I will actually need to bring in, this is why I need to have the smaller abacuses. I can bring in my 2 abacuses. There's my full abacus with 100. I'll just get this one to work as well. So again, if I put those 2 next to each other, I've now got 110, and you can see the 90 that makes 200. Just put them together like that to make my 2 whole hundreds. 140 plus what equals 200? Well, that's a whole 100. With this one, I'll just get my 4 10s. And again, if children work together, each with an abacus or on a table, there's 140. 40 and 60 makes 100. 140 and 60 makes 200. What would that be for 300? And I don't have enough abacuses. So again, the children will say, well, it must be 240 and 60. What will go there? We could have 340 and 60. That makes 400. All we're doing is making links all the time and getting the children used to seeing those number bonds going together. Just to conclude, going into some of the stuff we looked at yesterday with that little trick we looked at for making bonds to 1,000, let's look at the same thing for bonds to 100. We just saw 54 add 6 is 60, add 40 makes 100. 39 add 1 makes 40, add 60 makes 100. 72 add 8 is 80, and 20 is 100, and 51 and 9 that is 60, and 40 that is 100. We ended up with 4 number pairs, but if I was to write them as a kind of column, if I wrote the 46 there, the 28 there, the 61 there, and the 49 there, what you'll end up seeing is a simplified version of what we did yesterday. I'll just rub those out now, rub those out there, and what you can see is 90 and 10, 90 and 10, 90 and 10, 90 and 10, or the 9-10 pattern. If children get used to doing it visually first of all with the apparatus, and then make that link. So if I've got a number like 37, well, I add that one is a 9, and that one is a 10. 90 and 10 makes 100. Again, I would not teach them that trick until they've seen it all visually, then you can start to adapt it. If you remember yesterday, we extended that activity, so we had something like 763 add what, or 458 add what. Let's do it in stages. 763 and 7 makes 770, and 30 makes 800, and 200 makes 1,000, and we do that with resources like we looked at yesterday with place value counters. 458, add my 2, gets me to 460, add 40, gets me to 500. Add 500 makes 1,000. Or let's one more, 815 add 5 is 820, add 80 is 900, add 100 is 1,000. But what we end up with, as we saw yesterday, is 9, 9, 10. 9, 9, 10. 9, 9, 10, or 900 plus 90 plus 10 equals 1,000. Just that really quick trick. That works with pretty much anything. If I want to do decimal bonds to 10, well, 7.2 add what makes 10? Well, 7.2 and 0.8 makes 8, and 8 and 2 is 10. 5.6 add 0.4 equals 6, and 6 and 4 makes 10. If we're doing 2 decimal places, same thing applies. 3.78, 3.78, I've got to add 2 hundredths to that, which will get me to 3.8. I then add another 2 tenths, which gets me to which gets me to 4, and then I add 6, which gets me to 10. We've still got a 9, 9, 10 pattern. It even, ridiculously, adds to a nice little magic trick that you can do for the children in year 5 and 6. I've got the number 563,278. What's the number pair to a million? Again, if you write it horizontally, it looks like a magic trick. Horizontally, it's 436,722. Children think, whoa, how have they done that so quickly? 181,734, add 818,266. How on earth do you do that so quick? All we're doing is we're going, I'll write it underneath, 9, 9, 9, 9, 9, 10. We're making every single column, because what we've ended up with is 900,000, add 90,000 is 990,000, add 9,000 is 999,000, add 900, add 90, so we're on 999,990, add my 10, gets me all the way to 1 million. It's just a nice little trick that works for absolutely anything. Last but not least, we're just going to look at decimals. You're looking and thinking, where's the decimals here? Well, actually, this is the decimal equivalent of number bonds to 10. What we've got here is an egg box that's got 5 cubes, but actually that egg box is 5/10 full, or a half full, or 0.5 full. If each of these is 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, or 5/10, we can see we need another 5/10 or another 0.5 to make a whole. If we look at this particular egg box, we can see it's 6 add 4 is 10. Yes, but it's 6/10. Add 4/10, or 0.6, add 0.4. The final example that we see here, we can see that it's 9/10 full, or 0.9, that's 0.5 or 0.4. It's 9/10 full. If we add one more tenth, we've got 0.9, add 0.1, equals a whole. Whichever box I get, what we can see here is 0.8, add 0.2. equals 1 whole. If I want to do number bonds to 2, then I just need a full egg box. And what I've now got is 1.8, add 0.2, equals 2. Doesn't matter what number I want to do. If I just build it up a little bit, just drop another couple of blues. I'm going to fill my blue one up there. Let's have a see what I've now got. I've now got 3.6. What's my number bond? Well, 3.6, add 0.4. equals 4. So you can pretty much visualize anything using resources the children are already familiar with. And thank you very much for joining me today for looking at number bonds. We've gone all the way from number bonds to 10 to decimal number bonds to 1 and 2, 3, 4 and 5. What we've seen are lots of visual ways, we've seen games, and we've also seen loads of little songs that help support the understanding of number bonds to 10, number bonds to 20, and number bonds to 100. We can see now how easy it is to visualise it and to support the children's mathematical understanding. There's probably hundreds more games we could have played, but I hope you enjoyed the ones that we played today. I look forward to seeing you all tomorrow, and we're actually going to be looking at mainly Key Stage 2 number games that develop just mental arithmetic fun. Look forward to that. Thanks for joining me, and I shall see you all tomorrow.
Thanks very much for joining me today. I hope you've had a useful session today. As you've probably seen, it's been very much about Key Stage 1, about learning number bonds and then developing them into Key Stage 2 with similar models and images. We've also had quite a few songs today, which I hope you've really enjoyed. that have been taken from the Number Fun portal. Tomorrow is number games. It's dice games, it's digit card games, just fun games that kind of take what we've been doing and developing it into a game-based approach to playing with number. That will then take us into next week, which I'm going to give you a full outline tomorrow as to what next week's program is. Primarily next week, we're going to be looking at kind of early years and key stage 1 mathematical models and images. So hope you've enjoyed today, and I'll look forward to seeing you all tomorrow for day 10. Thank you very much. See you later.